All right, so we have this question here. It says the table shows the distribution of lifetime of a sample of car batteries. All right, so we've been given our class limits here, the lifetime in hours, and our frequency here. So the question says, do the following. Part A, rewrite the frequency table using class boundaries instead of class limits. Okay, so usually when the reason why we convert class limits into class boundaries is usually to accommodate for any decimal numbers. Basically, we're trying to close the gaps between the class limits. Okay, we're trying to close the gaps, right? So, what we need to do, the first thing we need to do is we come to our class limits, which are here. Okay. Then we look at our first class. The upper limit is 99, and we go to our second class. The lower limit is 100. Okay. For our upper class, upper limit 99. The next class, lower limit is 100. So you just subtract 100 minus 99. That gives you 1. Okay. Then this difference of 1, we divide it by 2. That gives us 0.5. So what we are going to do now with this zero point 0.5, all the lower limits, which are on the left-hand side, all these lower limits here, you subtract from zero point 0.5. Okay, so 90 minus 0.5, 89.5. 100 minus 0.5, 99.5. 110 minus 0.5, 109.5. Okay. So the lower limits, you subtract 0.5. Then the upper limits, which are here, you're going to add plus 0.5. So 99 plus 0.5, 99.5. 109 plus 0.5, 109.5. 119 plus 0.5, uh-huh, or plus. Mm-hmm. Mm-hmm. We'll come to the frequencies. We'll come there. Just hold on. Yes. So all the upper limits you add plus 0.5. All right. And as we can see now with our class boundaries, there's no gaps between the classes. Okay. There is no gaps. Okay. As you can see, 89.5 to 99.5. And you can see in the next class it starts 99.5 to 109.5. Then you see in the next class, you start from 109.5 to 119.5. So basically, we've closed the gaps between the classes. Okay, that's what's the purpose of the class boundaries. Then, so that's part A. Okay, we've made our class boundaries. Part B, they've said compute the mean. okay, which is the average. So for the mean, the formula for the mean, it's x bar equals summation of the frequency by the midpoint divided by summation of the frequency. Okay. So in our table, we need to get first our midpoints. Okay. So to get the midpoint, it's just your upper class boundary plus your lower class boundary divided by 2. So here you can see for our first class here, okay, 99.5 plus 89.5 divided by 2, you get 94.5. For the second class, 109.5 plus 99.5 divided by 2, you get 104.5. For the next class boundary, 119.5 plus 109.5 divided by 2, you get your class boundary. Okay, and what we can see is, we get our midpoint. And what we can see is our midpoints are increasing by 10. Okay, and 4.5 plus 10, 104.5. 104.5 plus 10, 114.5. 114.5 plus 10, 124.5. That's how you get your midpoints. Okay. Then after you've got your midpoints, the next thing you need to do is you need to multiply the frequency by the midpoint. Okay. Each frequency multiplied by the midpoint, so 1 times 94.5, 94.5. 9 times 104.5, 940.5. Okay. All the frequencies, you are multiplying them with the midpoints. Okay. So these are the values you're supposed to get. Okay. Frequency multiplied by midpoint. So these are our values. So Mr. Kennedy, you are asking on what? Where was your question based on? Oh, okay, okay. Yeah. Think. 154.5. Yes. Okay. Thank you. After that, colleagues, after you multiply the frequency by the midpoint, you just total up this column. You add all these numbers together. All these numbers, you add them. You get 13,410. Okay? All these numbers, you add them up. Then our frequency also, we need to total up our frequency. Okay, so we add all the numbers in the frequency here, we get 100. Okay? So to get our mean, as I said, it's the summation of the frequency times the midpoint, this 13,410, divided by the total frequency. So you say 13,410 divided by 100, and you get a mean of 134.1. That is our mean. Okay. The summation of the frequency times the midpoint, Okay, which is given as sigma, like this, sigma fx divided by sigma f. Okay, so 13,410 divided by 100, you get 134.1. That is our mean.